So, properties of polygons. Okay, well, what is a polygon? That means a many-sided shape. Boom. There's a polygon. Looks weird, but there it is. That's a polygon. It could be a triangle. A triangle is a polygon. We could have a rectangle-ish shape. That's fine. There's a polygon. These are polygons, multiple sides. But something that we're going to focus on today is the angle measures. All right. Well, what do I mean? Well, how many degrees are in a triangle? 180. 180. We have 180 degrees in a triangle. So what if I had a rectangle? Well, how many degrees are in that?
360.
That's true. But why do we know that?
Because if you flip a triangle, rotate it, and then it's two.
Yeah, it's two triangles, right? I have 180 in this triangle and 180 in this triangle. Okay, so a total of 360 degrees in that. Well, what if I had a pentagon? Now, it's going to be harder to see the triangles in a pentagon than in a rectangle or anything. But we can choose a vertex. And watch what I do from this vertex. I connect what are called diagonals. So these things in red, those are diagonals. A diagonal is drawn from a vertex. So some of you don't understand what a vertex is. A vertex is a point. That is a vertex. It is not a side. It may be used to name an angle, but it is a point. So diagonals are drawn from a vertex to another vertex. So that's a diagonal. Is that a median? Nope. Is it an altitude? Nope. Is it a perpendicular bisector? Nope. A diagonal is drawn from a vertex to another vertex. Now I can see I've drawn from this two diagonals. So I have 180 in this triangle, 180 in this triangle, and 180 in this triangle. So a total of how many?
540.
So a total of 540 degrees. Let's do one more. Let's do a heptagon. If I can even draw it. Here's a heptagon. What is a heptagon? A seven-sided shape. That's a heptagon. You okay, Victoria?
It's a beautiful heptagon.
It's a beautiful heptagon.
Your artwork.
It has been dropped too many times as a child.
Thank you.
Okay, so I'm going to choose one of these vertices. It doesn't matter which one. Maybe I choose this one. And I draw all the diagonals. So I have 180 in this triangle, 180 here, 180 here, 180 here, and 180 here. So 180 times how many? 5.
900.
No, 180 times 6. How did we get 5? 1, 2, 3, 4. Oh, it is 5. Derp, derp.
900.
I can't count.
Can't wish it was 6. It'd be 1080 then.
Okay, so 180 times 5, what do we get?
900.
900 degrees in a heptagon. So this is the sum of the angle measures. That's what we've been doing here. Well, maybe we can see a pattern. Right, so I'm going to erase this top portion here. And let's see if we can see a pattern using this. All right, so let's say this is the number of sides. Let's say this is the number of diagonals. And let's say this is our angle sum. Now, rather than just write the number, in order to find the pattern, I'm going to write down how I got it. So we start with a triangle. A triangle has 3 sides, and a triangle is not going to have any diagonals. You know, if you don't believe me, you know, what am I going to connect that vertex to? You know, no diagonals, but I have 180. So 180 times, I don't know, 1.
1.
All right, let's say I have a four-sided shape. Now, how many diagonals do I have here?
1.
1. Okay? And how did I get that? Well, 180 times 2. All right. If I have a four-sided shape, how many diagonals do I have?
4-sided?
A five-sided shape. 2. And I did 180 times how much?
3.
Times 3. Okay. We skipped 6, right? And we went to 7. Okay. So 7 times, or 7, how many diagonals do we have? 1, 2, 3, 4 diagonals. 4 diagonals. And we did 180 times 5. Okay? So let's guess what 6 would be. So if I had 6 sides, how many diagonals do I have?
3.
3. And I have 180 times 4. Now, these diagonals don't seem to be directly related here, but it seems I could see a quick relationship to the number of sides in what I'm multiplying by. So do you see a pattern here with the number of sides and what I multiply by?
2 less.
2 less, okay, all the time. So, let's use that to write a formula. The angle sum is going to equal, well, 180 times, well, what?
Number of sides minus 2.
Yes, where n is the number of sides. That's going to give us our angle sum. Any questions on that? So for example, if I had a 36 gon, what is a 36 gon? A thing with 36 sides. And I wanted to know, well, what's the angle sum of that?
180 times 34.
I'm going to do 180 times 36 minus 2, which is 180 times 34, which gives me how many degrees?
6,120.
Any questions on how to find angle sum?
No, but please leave that up there.
Anyone confused on how we got that? Any confused how to use it? If you memorize this formula, okay, that will help you immensely. Put it on a flashcard. There are going to be lots of formulas. In fact, we're going to do 3 formulas today. So this is the first one. We're about to go on to the next one. It's the total of angles, total of the degrees inside. So that's the inside.
Okay.
Sum of the angles. Okay. If I call you regular,
Thank you.
what do I mean?
Basic.
You're basic. There's nothing strange about you. You're normal. Whatever, boring. You're regular. All right, if I call a shape regular, like this, then what does this appear to be?
A square.
This is a square, okay? We would call this a regular quadrilateral. Maybe I have now, I'm not the best artist, obviously. You know, you've seen my artwork.
It's awesome. It's okay.
But I'm going to hash mark these sides, which tells me they're all the same. And this would be a regular pentagon. And I'll try really hard to get the hexagon, but I'm probably not going to get it. Okay, I hash marked the sides, so this is a regular what? hexagon. Alright, let's go to the quadrilateral. How many degrees are in this angle?
And
360.
90 perhaps?
Yeah. Oh, well, I got it wrong anyway.
Because each of the angles in a square are 90. But how many degrees are in a quadrilateral? Well, 360. And how many sides are there? 4. And that gives me 90. Now in a pentagon, how many degrees were in the whole thing? We just calculated that in your notes. How many degrees total in a pentagon?
oh, it's 540, isn't it?
540. Now if I wanted to know one of these angles,
Divided by 5.
divided by 5. So how many degrees in one of them?
108.
How many sides does a hexagon have?
I'm sorry, how
6.
did we know that it was 540?
Because previously we had calculated it, but if you don't know, we would do 180 times n minus 2. Use that formula from before. 180 times, we have 5
3.
sides, so 5 minus 2, so 180 times 3 is 540. And that's how we know. Well, we had just drawn it on the previous slide. We had drawn a pentagon, remember? And we drew this, and we saw 3 triangles from there, right? 180 times 3. So that's how we knew. Now we haven't actually done the hexagon, so let's go ahead and do that. We have 180 times 6 minus 2, using our formula before. And we have 180 times 4, which is how many degrees in this?
720.
720. So if I wanted to know one of these angles, what would I do?
Divided by 6.
So 720 divided by 6,
It's 12.
which is how much?
120.
Notice how it's increasing. But hopefully, you're seeing what we did. What do? We take the total number of degrees and divide by what?
And divide it by how many sides?
Right. So we have the measure of one angle. This only works if it's regular. If it's anything else, then we can't do this. But the measure of one is going to be 180 times n minus 2. This gives us our total, and then we divide by the number of sides that we have.
Mr. K, I have a question.
Yes.
How'd you get 108 degrees for the regular pentagon?
We took 540, which is the total degrees in the whole thing. So there's 540 degrees in this whole thing. And then we see there's how many angles? 1, 2, 3, 4, 5. So we divide it by 5.
Well, what's that 180 parentheses n minus 2? And
That's us figuring out this 540.
oh, okay. I was getting confused. I was like, okay, I see now. Thank you.
Yes, Jacob.
Is this on our take-home test, or is this the other check?
This is the new chapter. We aren't reviewing. You have all of your notes, your textbook, and whatever else, YouTube videos,
Was tomorrow?
to go ahead and use, just not people.
Was tomorrow's note? Was yesterday's notes also the next chapter?
No,
Okay.
that was the hinge theorem is on your
Okay.
test. All right. Any questions on this?
No.
So let's say we have let's do a 36 gon. We'll have a regular 36 gon, and I want to know what is the measure of one angle in that. I obviously don't want to draw a 36 gon and figure it out that way. So I just have a formula that we're going to use. So the measure of one angle, MOA. Measure of one angle, MOA. The measure of one angle is, what's our formula, Noah? What's our formula for the measure of one angle?
180 parentheses n minus 2 over n.
Alright, so what am I going to put in here? 180 times what?
6 minus 2.
divided by, because if I have 36 sides, then how many angles do I have? 36. The number of sides equals the number of angles. And if it doesn't, then it is not a polygon. You have something else. So we have 180 times 34, all divided by 36. So what do we get for the measure of one angle?
170.
Okay, 170. Quite obtuse, huh? Now eventually that's going to approach what number do you think?
180.
So that's actually going to be a calculus concept called a limit. So let's see if we can figure out the limit. Let's say I have a 1,000 gon. We're getting close to what shape then? A circle. Okay? We're getting very close to a circle. And yes, my honor students have made the connection. 1,000 gon, we're getting close to a circle. That would be in Flatland, the
We're supposed to
priestly
know that.
class.
We're supposed to know that.
All right, so let's find the measure. Listen, let's find the measure of one angle inside 1,000 gon. So our formula, measure of one angle, is going to be 180 times 1,000 minus 2 divided by what? 1,000. So do we actually think this is going to approach 180, or is it going to approach something else? Well, it's going to approach 180. Why? Because this piece, if I just look at, now this is just look at this piece. As those numbers get really big, what is that getting really, really close to?
A circle.
What number? What number would that, okay,
180.
1 million.
okay, 1 over 4. What's that? About 0.25.
Correct.
2 over 4, what's that?
0.5.
0.5. 3 over 4, that's
75.
now, if I put 3.99999 over 4, this is going to get close to what? 1. It's going to get really close to 1. Well, look at this. That's 998 over 1,000. That's getting really close to what number?
180. 1.
No. Look at what I wrote on the board. The 998 over 1,000. That gets really close to what number? 1, which means if this is getting close to 1, this whole thing's getting close to, Justin just called it out, 180. Okay, so let's actually figure out what it actually is.
179.64.
So we have 180 times 998 divided by 1,000, which is
179.64.
now here's the thing. We'll never actually get to 180, but we'll get really close to it.
Could you draw that angle, please?
There.
Yeah, I'll draw 1,000 gon. We'll spend the next 50 hours drawing 1,000 gon. Okay, so far, let's rehash. We have the angle sum formula, which is what?
180 in parentheses n minus 2.
Okay, then we have the measure of one angle. What's that?
Same thing divided by n. Well, all both.
All right, let's get the third thing that we need to know for today.
Honestly.
It's just like, I can't even.
All right, here's my very sad quadrilateral. And let's say that this measure of this angle is 70 degrees here. And let's say I just take this side and I just extend it out further.
No.
What's the measure of this angle?
That would be 110.
110. And how do you know?
Because it adds up to 180.
Huh?
It adds up to 180.
Yes, it adds up to 180. So these are supplementary angles. Okay? That angle right there is called an exterior angle. And the measure of an exterior angle is going to be 180 minus the interior angle.
Can we already kind of do this?
Yeah, but that's not the new thing.
Oh.
Okay, here is the new formula. The sum of the exterior angles is going to equal 360 degrees. No matter the shape. So if I have a square, let's just use my pathetic square right there. So these are all 90. Let's just prove it with that. If I extend these all out like this, if this is 90, what's this?
90.
Okay, if this is 90, what's this right
90.
here? 90 and 90. I don't want that because that's confusing. 90. How many of them do I have?
4.
4.
So I have 360 degrees. Okay, now let's do a different shape. Okay, just watch how I'm drawing them, because you're right. I'm going to say that this is a regular pentagon. I know it doesn't look like one, but then each angle is 108 degrees, right? We're just going to make it regular. It doesn't have to be. So I'm going to extend these out. I'll go the other way this time. I extend these out. Now I have to go one way. I can't go both ways, because then there's no property that I'm going to be able to use. Okay, if this is 108, what's this angle right here?
72.
And if this is 108, what's this angle right here? Okay, because they're supplements. If this is 108, this is 72. This is 108, 72. And again, 108, this is 72. So 72 times how many?
5.
What's that equal?
That equals 360.
360.
I should have known that.
Okay. Now, mostly we're going to need this 360, but every now and then you need to know the angle sum of a different polygon in order to find one of the interior angles. Any questions on this sum of the exterior angles equaling 360?
No.
Kinda.
Third thing.
That is the third thing.
Yay.
So, any questions on that?
So, yes. So whenever you extend it, will it always be the same number around?
Well, it depends. Okay, it could be.
Like on the one that
Okay,
you just did.
just look. This is a trapezoid. This is a right trapezoid. So that's 90. That's 90. Let's say this is 100, and let's say then that this is 80. So then, if I extend these out,
Yes.
this one's 100. If I extend this one out, this one right here is 90. If I extend this one out, this one is 90. If I extend this one out, this one is 80. It has to do with these are supplements, 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 supplements. Okay? If it's a regular, then it's going to be all the same. But this one's not regular. All right, let's do an example where we have to use angle sum for something other than just finding the angle sum. So here's a pentagon. Let's say this is X. Let's say this is 100. Let's say this is 120. Let's say this is 110.
Oh my.
And let's say this one right here, maybe this one's 90. How do I find X? Well, I'm going to have to subtract all these numbers from something. Well, if it's a pentagon, I'm going to walk you through all the steps, but we know that the angle sum in a pentagon is 540, because we've already calculated that. So, the angle sum is 180 times n minus 2. That's our angle sum. We have 5 sides, so 5 minus 2. So 180 times 3 gives us our 540. We aren't done yet. That tells me how many total. So if I add all these up, my total is 540. I'm going to do 540 minus 100 minus 120 minus 90 minus 110, and that's going to give me this X.
Okay, hold on. Where'd you get all those? Because I just looked down and write the little shape, and you had all that stuff up there. What's this stuff on the right?
Angle
All
sum.
this stuff on the right. You tell me, what is this stuff? What am I doing right there? Think, what am I doing right here based on what we've talked at this class?
Oh gosh. Okay, I see it. Okay. So there's 5 different sides, you subtracted 2, and then, okay, I got you. That's how you got
Okay,
it.
but what was I doing?
Finding the angle sum.
I'm finding the angle sum. Why do I find the angle sum? Because I need to know that in order to find this missing angle. I need to know how many degrees are in it total.
I got it.
All right. So then I take that 540 and I subtract all the other angles for it. What is the measure of angle X?
120.
Is it really 120?
I think.
Yeah, that's it, right.
Okay. Any questions on that?
No.
Okay. I gave you a chance. If you had a question and you didn't speak up, that was your chance. All right. Here is a regular octagon. That means what about all the angles?
They're equal.
They're equal. Now there's 2 ways to do what I'm about to do, but I want the measure of angle 1.
Okay,
The long way. I'm just going to describe the long way. I find all the measure of one angle, and then I subtract from 180. That's the long way. You can do it that way. The easy way, the sum of the exterior angles. Sum of the exterior angles is 360. Now, if this is regular, that means all the angles are the same, which means all the exterior angles are the same. So all I have to do is 360 divided by how much?
8.
8.
45.
So this is 45.
45.
Which means this is 135 in here, if I wanted to know that. Suppose I had a 50 gon, and I wanted to know the measure. It's a regular 50 gon. And I wanted to know the measure of one exterior angle. What would I do?
You would do 360 divided by 50, and you would get a grand total of 7.2.
Yes, that's correct.
I did my calculator.
Okay. Go ahead and put your notes away. Get out.